Example number 1. Does tuning a car engine improve the gas mileage? A sample of 8 automobiles were run to determine their mileage in miles per gallon. Then each car was given a tune-up and run again to measure the mileage a second time. The results are presented in Table 11.1. The sample mean mileage was higher after tune-up. We would like to determine how strong the evidence is that the population mean mileage is higher after tune-up. Use alpha 0.01. From step 0, we want to write down the given information and the question. The table given us all for the information. So we notice that they already calculate for us the difference. In this case, they use the difference is after minus before. And they got all positive number, 1.68, 0.87, 1.52, and so on. How do we get those numbers? It's because they do after tune-up minus before tune-up. And the number positive is show that after tune-up is higher. That is for the sample, and we want to know what if the population mean mileage is also higher. So that is population mean, the notation is mu-d. Higher is mean higher tune-up is mean the difference have to be greater than 0. That is the average difference. And that is the question. So from the given information, we calculate the difference we do after minus before. We got the 8 difference number, 1.68, 0.87, 1.52, and so on. We will enter those numbers in Excel, and we calculate the sample difference average. We use average equal for D bar, and the answer we got is 1.20625. SD, we use STDEV, we will get 0.37317. And the question is, we want to know the population mean is higher after the tune-up. Higher after the tune-up, that means the difference have to be positive. Now, under the new, we will use the question to set up for the null and alternative hypothesis. Under the null, we will assume it's always equal, so it will be equal 0. And opposite to that will be, in this case, could be greater than 0. We will use right tail. Alpha in step number 2 in the problem is given 0.01. Step number 3 is test statistic. So D bar is 1.20625 minus mu D. Minus mu 0, mu naught. Mu naught, you will look at the null. Under the null, we will assume that the mu naught is 0. And that will be always for this section. SD is 0.37317 divided by 8 because we have 8 cars. We calculate this number and we got 9.1427. Step number 4 is compute the p-value. We will use the right tail as is said in step number 1. So the yellow area is the right tail. And that is the p-value. For this point right here, we will put step number 3 number. That is the test statistic, 9.1427. To calculate this p-value, I use the GeoGebra. I make sure that is the T, the student, because we are using T in step number 3. The degree of freedom is 7, and the number that I put is 9.1427 in the parentheses, and the very last number 0 is the area, and that is the p-value, and the p-value in this problem is 0. Now step number 5, we make a decision. The p-value is 0 and the alpha is 0.01, so we can say that p-value is less than alpha, so we reject the null. Now what is the conclusion? The p-value is less than alpha, we reject the null. We go back to step number 1. The null is, under the null we assume that the average difference in the population is 0, and we reject this. So it's gone. So what do we have left? We have left is the mu d, which is the population mean is greater than 0. So this is exactly the question asking you. That's what we have left. And the mu d greater than 0, it meaning that the population mean mileage is higher after tune-up. So we write out the conclusion that we have enough evidence or we have strong evidence that the population mean mileage is higher after tune-up.